6.4. We're going to begin by looking at even and odd functions. We haven't done this since module 4, I believe it was. So just really quick, graphs of even and odd functions make it easy to identify the type of functions. Remember that an even function has a line of symmetry along the y-axis, and an odd function has a 180-degree rotational symmetry. So that's when it can turn. Okay, it'll be, if I can turn it 180 degrees like 92 times, then it's odd. So you're just going to go through here and you are going to identify all of these as just even, odd, or neither. So if it's not symmetric to the y-axis, so in number 2, there's symmetric to the y-axis, therefore that would be even. Number 1, I need to just just go to my origin, and I can see that it's not symmetric to the y-axis. So now it's either odd or neither. So I look at the origin, and I see this piece right here. I look at just the right side, and if I turn this way, will that blue piece line up on the red piece? And my answer is yes, it will. Therefore, this is odd. And if I couldn't, for example, if I look at number 6, here's my y-axis. Obviously, it's not symmetric to the y-axis. And if I look at the origin, there's not even anything over here in this area for me to rotate around. So that is an example of a neither. So you have an example of an even, an odd, and a neither. And you're going to go through and do the same thing with the rest of those graphs, 1 through 9. All right. In this set, in class, we have gone over the sine graph, unless we haven't done the task yet. If you're looking at this without doing the task first in class, wait till we go over this in class. We have to go over the basic sine graph first. So I'm going to go over this as if we've done the task. So please make sure, if you don't understand what I'm talking about in the video, just wait until I do the task in class with you guys next week, and then it should make sense for you guys to go back and finish this. So transformations, that's something that you started to see in Math 2, and I just briefly want to talk about what the different transformations are. So we are actually going to do 10 through 13. You could actually type in, actually, that's what I would like you to do. If you type in y equals x squared into Desmos, and if you don't remember what all these different pieces, these are the additions. So my parent graph is y equals x squared. These are the extra pieces. That's what is making that transformation happen. If you don't know what those 4 things do as far as transformations go, put them into Desmos, write down what happened. How did that graph move? It went left, it went right, it went up, it went down, it got wider, it got narrower, it went upside down, it had a rotation, something. Describe what those transformations are. And then we're going to use that basic knowledge of transformations, up, down, left, right, reflections, wider, narrower, to match these 6 graphs with the 6 sine graphs. But before we do that, we need to discuss what the basic sine graph is. So in class, we will have gone over this already if you waited for the task to be done for you. So my basic sine equation is y equals a sine of omega x. A stands for the amplitude. And this tells us how high the graph goes. Does it go up to 4? Does it go up to 7? Does it go down to 3? And the amplitude is always positive. So that number, if it's not if there's nothing that you see in front of sine, then that number is 1. If I see a number in front of sine, then it will change. The W, which is omega, it's a Greek letter. Okay, it's a funky little W thing. It's the lowercase omega. This helps me find the period. And the period is how fast the graph goes. So the formula for the period is P equals 2 pi over omega. The reason it's 2 pi is because the full cycle of our unit circle is 2 pi. So all the way around. And omega is what we are. So we've been doing this, you guys, when we've done, oh, what is the angular speed? That's what we've been doing. We've been getting a quick look at finding how fast something is moving, but we've been looking at it from 360 degrees. So 360 degrees and 2 pi are the same thing on your unit circle. They have the same position. One is angular, one is linear. So we're dealing with the linear part of it. And then omega is how fast it's moving per second as it's moving around the circle. The bigger omega is, the slower your graph is going to move. So something to think about. Again, we will have discussed this in class. So if this is not making sense to you, then wait until we do this task in class, but you can do the ready and the go to get ahead. So I'm going to come back here, and just to get you guys started on this, sorry, my computer's being a little weird right now. To get you guys started, there it goes. Okay. If I look at just the basic things for the transformations, like in B, I see a +2. That means my graph goes up 2. So I want to look for my basic sine graph that is moving up 2. And in class, we will have discussed that the basic sine graph, if I put a coordinate plane in here, the basic sine graph is 2, 3, 2, 3, 4. So here would be 2 pi, and it would start at 0. Okay. So this is the basic look of a sine graph. One cycle though, only one cycle. And it would keep going and going and going. Keeps doing this all the way through. So there's my very basic, okay, hold on, my computer's being silly. Okay, hopefully it continues to work. It's having some moments. Okay, so let me put this back in here. Okay. So the reason I know to graph this, if I have y equals sine of x, my amplitude is 1 because there's nothing in front of sine, so I have to go up to 1, down to -1. And the period for your sine graph is 2 pi. So by 2 pi, it needs to be finished. So in class, we will have gone over this in detail. So I'm not going to go over that in detail right now. So I'm going to use this, and I'm looking here, and I want to use the transformations that I have discovered from 10 through 13, or refresh my memory of, to find or to match these graphs without having to do a whole lot of work. So in B, I have the sine of x, but then I'm moving it up 2. So I'm looking for a graph that has an amplitude of 1. This one does not have an amplitude of 1. That does. Okay, not 16, because, 16 shows that it's up here, but where is the graph centered? So then we need to think, okay, the graph is not on the x-axis anymore. It's been moved. This one, here it is down here. Okay, this one centered at 0. This one centered at 0. Amplitude, nope. Amplitude, nope. So that leaves me with 16 and 17. And then I need to think about, okay, what did this tell me to do? It told me to take the graph up 2. Therefore, the answer is 16. So 16 is going to match with B. Hold on, you guys. All right. Oh, that was a longer break. Okay, so we just matched 16 with B because it took the sine graph and moved it up 2. So kind of think about other things that might be happening with some of the numbers here, what negatives are doing, what positives are doing. Please try not to use Desmos. Again, we'll have gone over how to actually graph these in class using the amplitude and the period. So if you're not understanding this, because I'm really not going to explain this any more than what's on here, then wait for wait for me to do the task in class, and then you'll have other notes, okay? Now, if we did do the task in class and you're watching this again and you still don't understand it, then you need to be coming in and asking for some help, okay? Come in the morning, come in at lunch, and I can go over how to graph a sine graph with you again. But try not to rely on Desmos, okay? You're going to have to be able to do this for a quiz and a test. Okay. Moving on to the go. I'm really not going to talk about this. You are just identifying which things move clockwise and counterclockwise. Clockwise moves to the right, counterclockwise moves to the left, and if you're not sure, Google it. If you really do not know, Google for like sprinters racing around the track. If you don't know the way that we run around a track, then Google it. If you don't know which direction we go in a roundabout, things like that, Google it, okay? There's nothing wrong with using Google for this. And then hopefully that will help you understand why we use counterclockwise around our unit circle instead of clockwise, that we use counterclockwise. Okay, that wraps up 6.4. Questions, come and see me, ask me in class, let me know. If you were not able to do the set, make sure you go back and do that after we do the task in class.